Well, hello, radio people. First of all, I want to thank everybody for all the emails and the comments and those who have joined my YouTube thingy up there. This is in response to this thing. If you look back at a recent posting, this is a broadcast band Preselector we built. Remember this monster? All right, well, we're going to build another one. We're going to do all band. And I've designed it around response of about 10 or 20 kilohertz, way down into VLF, and up to the last measurements I took were 32 megs. So it's all band, as far as I'm concerned, if you're talking short wave, long wave, medium wave. But this AM one works. The recipient is of the actual unit. This is the prototype. Has got it in final test right now, so we'll see how that goes. But I'm going to call this YouTube thing a design engineering nightmare, because this is what goes on behind the scenes before you build these things. And because of some of the emails I got, I just wanted to clarify a few of these modules that we've built and just go through them really quick. There were a lot of questions, and we'll try to show you the documentation and so on. As you can see, I've rebuilt a whole bunch of these things and made them for wideband, so we're good down below, well below 30 kilohertz and up above 30 megs. So let's quickly go through this. Here's a closer look at the toroid that I built. You can see over in here, that animal. I built another one. We are running, let me get some paperwork here, 38 turns on a 43 core. I wanted to get way up so I could get down into the LF and VLF bands. You can wire this any way you want. I did it kind of like this, just tapping, and I'll show you how I did the tapping as we go. Just wind the full thing and then figure out the taps later. The last thing you'll do is to put in the 50 ohm tap. I did everything at 4-to-1, so the reactances are 4-to-1 for the reactances in microhenries and millihenries are 4-to-1 of the actual impedance you need, and that's just to keep the losses down to a minimum. I see far less than a dB of loss through this thing. It's probably half a dB or a quarter, so I don't know, but it's insignificant. But anyhow, what we did to get that is this is bifilar wound to make it easier on me. And there's the 28, what did I say, 28 turns, I think, in there. What I did is I came in, and get a pointer, on the input, this blue wire, and started going around testing the coil. I put a pin, a sewing needle, into the probe on my reactance meter, and just started poking through the insulation until I found the spots that I wanted. That could have been done with calculations, but real world is always better, and it may be a little hokey, but that's how it works. And wherever I found a point that I liked, I just pulled the wire up a little bit and soldered the taps. And as you can see, we have the 6 taps here. We're going through, let's see, 25 ohms, 50 ohms, 150, 300, 450, and 600 ohms. So we're going to get a pretty good match on the antenna there. All right, moving along, we come over to the preamp. Let me get some light there. This is the one I've been using right along. It's a two transistor affair. I'm using The input caps are 0.5. I've actually got them doubled up. Well, you can't see that there. Underneath, it's almost one microfarad. I wanted to be nice and flat down to I don't know, between 10 and 30 kilohertz. It's actually receiving at 10 kilohertz. So, and I can hear Cutler submarine base at 22 or 21, whatever that is, kilohertz. So that's taken care of. That schematic is, incidentally, if you want any of this stuff, just do a screen grab. I hope you can get that. A note here, the input pot, or the output pot rather, you notice I'm coming in with a level control so we don't overload it. We'll just call this attenuator or RF gain or whatever you want to call it. You're going to get 15 dB of gain out of this thing over here. What I did was I pulled this pot up off ground by, that's a typo, it's 47 ohms off ground on the ground side. So when the pot goes to 0, you're actually at unity gain. So you turn the preamp down to nothing, and you have the effect of a straight-through wire. Again, if you're going to screen grab it, I guess you could do that now. Do it now. Okay. From there, we go to the... these are BB112s, Bravo 112s. You can see those those are also on other YouTube videos here. I'm using them back to back, anode to anode, because they're in series with the circuit, and we'll take a look at that. There it is. Get your screen grab thing out. Grab it. There you go. Grab that. Grab that. Are you grabbing? All right. High impedance isolation for the DC. We only need a little bit of current down through these guys. And the pot I'm using is, I've got 100K in there. I wanted to put in a meg, but that's fine. This thing at 0 volts here is going to be maximum 300 and something picofarads through this chain. And at maximum voltage, which is really around 7 volts or 8 volts, is going to be the lowest, probably, a handful of PFs, single-digit picofarads, maybe 10. The thing here, input and output caps for DC isolation, make them big so that you don't affect the effect of having caps in series. You know, then the value is less than the least, and you don't want to do that. So make these big, like 0.5 microfarads or something. So that's that. Hopefully you grabbed it. It's important to grab it. Here's the coils that we have for the various bands. You can see 1, 10, and 100 micro henries, and on the other side 1, 10, and 100 millihenries. And that combined with the capacitance here, which is, let me get this again. Here's the choke bank. In and out. So you have a series filter, very, very sharp. Those coils are, I don't know, somewhere between 150 200 Q. So you get a nice 10 kilohertz spacing, channel spacing. You get really nice tight return loss. I'm going to say on the order of, at the high end, on the order of 60 plus dB, and on the lower end, 28 to 36 dB. So any adjacent channel stuff just goes away like dead air. Now, the entire system's running on 12 volts. And since this only needs 7 or 8 or so, I'm using a regulator down here from the 12 volt supply. And it's marked 7. It's actually 9 volts. But I wouldn't go over 10. I think the devices are rated to 12 or so to be safe, but you're not going to gain anything. So use a, I don't know, 8 or 9 volt regulator and you're fine. You can use a 6 volt regulator and put a diode in the center leg. Pull that up above ground and get that voltage that you need. I don't know if I should try to demo this or not. I've got the gain set here at Unity. I've got the transformer tap here set for the middle of the broadcast band, and the Preselector filters here. This is also set for the middle of the Preselector band. The balun is tapped at the 50 ohm thing. I can turn that and you'll see a difference. But what we've got now, look at the mess. That's why I'm calling it a nightmare. Oh boy, a lot of clip leads. Oh, by the way, power supply requirements we're drawing, less than 25 milliamps. So you can get away with a little power. Make sure the power supply is really clean, though. Do a, let me grab a, here's what I'm putting in the supplies. Here's a little Pi network. 100 mics, and I forget, it's 300, I think it's 300 microhenry choke. So in and out, and the Pi network in between. Whatever hash is on your linear supply, do not use switching supply. Whatever hash is on the supply will be filtered out by that. And you get down around 1 or so millivolts of ripple. I'm sub millivolts on my supply here. You're not going to screw anything up in terms of adding noise to the system. All right, let's go over here. I'm going to turn, let's go back. Sorry if I'm making you dizzy. Here's a voltage control pot that feeds the BB112. All right, we're going to go from anywhere from 0 up to 9 volts with this pot. And I've got the radio set on. I've got the AGC turned off. And you can see I just touched it. Look what happened. Dead air. I'm turning the pot up, up, up. I hit the peak. I'm continuing to turn up. And see, it's sharp. It's really sharp. So let's get back to the peak. There. There's no sense in changing the tap thing. You won't see much change. A couple of dB with the antenna input impedance selector, but it is effective. And again, with all this crazy wiring here, I'm sure there's a lot of local pickup, so I'm not really matching. I don't know what I'm matching here. I'm sure there's radio signals bombing in on all these clip leads. And again, this switches all these guys on the where is on the Preselector. Here's a graph of, I'm sure if you've seen my other YouTubes, you've seen this too. These are the chokes. 1, 10, 100 microhenries, 1, 10, 100 millihenries. The pencil line here is the range of the BB112's capacitance range. So if you go down here and you look at it, we're over here, we're down at, it says 30 kilohertz. We're actually good down to, I don't know, 15 or 10 or something. This is purely theoretical. In the real world, it always comes out different. And at the high end, it says we're good to 55 megs. I've only measured it to 32, which takes me to the, near the top end of the HF band. So that's that. If You may have to look at, I'm sorry about this production, but you may have to look at this more than once. But those are all the things you can do a screen freeze and capture if you want. When this is put together, just like that animal, and it might be worth your while to check back a couple of days and see this is the AM only, and see how that was done. Again, a very clean power supply is important. Layout, grounding, coax interconnects. Take your time building it. It'll come out fine. Okay. Again, thanks everybody for emails through my website and joining my YouTube channel. I appreciate it, and thank you for all your comments. Bob likes that. All right, YouTube channel in 1KPR, Kilo Papa Romeo, and my website, bobsamerica.com. Thank you for looking, and sorry for the display of this nightmare here. Take care. Stay safe, everybody. N1KPR, we're out.